Hello students, welcome to Unit 6 Notes, Section 8.3. As you can see, I did some of the warm-up to save time. You can pause it right now if you would like to. I did these four proportions. I left them in a simplified fractional form. I could have approximated, but I think the exact value is what I was looking for solving these proportions. Definitely write these down. Feel free to pause the video. I also wrote the basic thing that this is asking me. It wants the ratio of side lengths. So BC over AB, AC over AB, and BC over AC for all three of these. I tried to color code them. This is for number 1, these are for number 2, and this is for number 3. So to write the ratio in number 1, we're going to need to know what BC is. Now, this is what appears to be a 45, 45, 90 triangle, right? You have this is 16 square roots of 2 and this is 16, which means that we have to have a 45, 45, 90 triangle, which means that if this is 16, that also has to be 16. And for these, it looks like if that's 10 and that's 10, that this will be a 45, 45, 90 triangle as well, making this 10 square roots of 2. Remember, the hypotenuse is equal to the square root of 2 times the length of the short side. And this appears to be a 30, 60, 90. So the short h is equal to the short times the square root of 3. H is equal to, h is equal to s times 2. And L is equal to short times the square root of 3. So it looks like we'll have, I already don't have room here. Let's move that over just a little bit. So it looks like h equals 4 times 2, so h is 8. L equals 4 times the square root of 3, so L is 4 square roots of 3. Okay, so this is 4 square roots of 3. This is 8. So now I'm good to write my ratios. So I'm going to say that BC is 16 over 16 square roots of 2. And it wants an approximate value, so I'll do that in a second. Okay, AC over AB is also 16 over 16 square roots of 2. And BC over AC is 16 over 16, which is exactly 1. So that's exactly 1. Let's do 16 over 16 square roots of 2. I never asked for AB. Yep, okay. So 16 over 16 square roots of 2. Notice I'm putting in parentheses. I want to make sure it divides that whole thing. So it's about 0.707. 0.707. But it wants the nearest hundredth. So 0.707, 0.707, oops, 0.707 is approximately 0.71. That's your nearest hundredth. So 0.71, 0.71. Okay, let's look at BC over AB. So BC over AB is, I'm also not going to have room for this. Going to have to do 2 of them like that. That will fit. Yep, we'll do that one over there. So BC is 10 over 10 square roots of 2. AC is 10 over 10 square roots of 2. And then we have BC over AC, which is 10 over 10, which is 1. So that one was easy. And now these is 10 over 10 square roots of 2 each. Oh, it's the same thing, 0.71. Okay. All right. And then in the last one, we have, hopefully we don't run out of room here. All right, BC. BC is 4 square root of 3 over AB, which is 8. AC is 4 and AB is 8, which is 1/2. That one's easy. And BC is 4 square roots of 3 over AC, which is, 4 square roots of 3 over 4. They wanted what? BC over AC? BC over AC. Yep. Okay. So 4 square root of 3 over 8. 4 square root of 3 divided by, 4 square root of 3 over 8. Notice I hit this arrow key to the right to get out of there. What you don't want is this. You don't want that. That is incorrect. Be careful. You got to get out of it and then divide the whole thing by 8. Then they want to what? 4 square roots of 3 over 4. 4 square root of 3 over 8. Yep, and 4 square roots of 3 over 4. So we get 0.86. So 0.866 simplifies to 0.87. And then double that really is your next one. We get 1.732. 1.732. 1.732 simplifies to 1.73. All right. So why did we do this warm-up? Well, we're going to be solving now. Let's say we don't have the ability of using the Pythagorean theorem. We don't have enough pieces of information. The angles are, what we're going to be doing is solving for side lengths and for angle measures, both side lengths and angle measures, depending on what triangle we're given. What we need to do, though, is we need to focus in on any angle other than the right one. We can't put anything in terms of the right one. I'll explain. Okay, this is what we're going to call trigonometry. So we're starting this lesson. It's a long lesson. It's on trig. Trigonometry comes from the Greek word trigonon and metria, meaning triangle measurement. Okay, so we're going to focus on 3 different kinds, and the first one is going to be the sine. The first one we'll focus in on today is tangent, but there's also 2 other ones we'll focus in on, which is sine and cosine. So I'll write, I can write that, sine and cosine. These are the 3 basic ones, okay? These are the 3 we call them 3 basic trig functions. We'll be doing sine and cosine for the next lesson. So the trig ratio using tangents in triangles. So for each pair of complementary angles, A and B, so that means that this has to be a right angle. That means C always has to be a right angle. Well, C doesn't. It could be A, B, or C. It doesn't matter. It could be R, S, or T. We have one right angle here. we can focus on these other two angles, A and B, and we can actually solve the triangle using them. We can never use the right angle. So A and B are the ones that are in question. So there is a family of similar right triangles. In each such family, the ratio of the length of the leg opposite A, the length of the leg adjacent A, is equivalent to the tangent of A. So what we're saying here is that tangent of any angle is equal to the opposite side over the adjacent side, making tangent simply equal to opposite over adjacent. Okay, and that's listed here. Tangent of your angle A is equal to opposite adjacent. So what does that mean? That means that the tangent of angle A, that would mean that the tangent of angle A is equal to the side opposite A. So we'll call that BC over the side adjacent, which is side AC. Now notice there's always three sides to a triangle. There'll be an opposite side and an adjacent side based on an angle, but there'll also be a hypotenuse, which in this case, this one is not used. So when you go to break it down, pretty much mark the angle it's asking you to find, like A, and then determine which are the adjacent sides. There's two of them. There's AB and AC because they both have A in common, right? So angle A has AB and AC. This one's not your adjacent because it's the hypotenuse. So these get categorized based on which one of these is the hypotenuse. So throw your hypotenuse down, always opposite the right angle. Then you have this adjacent side, and that forces this BC to be opposite. Okay, and that's it. So we can abbreviate the equation by saying tangent equals opposite over adjacent, or we can even say TOA. That is a way of remembering it. Remember it by TOA. Tangent equals tangent of your angle, notice capital T, tangent of your angle equals opposite over adjacent sides. All right, so write the tangent ratio for T and U. So here, the tangent of angle T, the tangent of angle T equals the opposite over the adjacent. Let's find out for angle T, what is what? Well, this is going to be the hypotenuse. Always, it's opposite the right angle. And then we have an opposite and adjacent side here. Well, this is the other adjacent side, not called the hypotenuse, but instead called the adjacent. And then we have our opposite. Look how far away that is and how close this one is. So the tangent here, the tangent of your angle, T, tangent of angle T, equals 3 over 4. And that's it. So all it wants you to find is your ratio. So tangent of angle T equals 3 over 4. Now it wants you to find angle U. So in orange, orange, I'll do the tangent of angle U. So tangent of angle U equals opposite over adjacent. So the tangent of angle U equals, and for angle U, it's a little bit different. Here's angle U. This is still the hypotenuse, but take a look. Look how far away that one is. That's your opposite side. And this one now is your adjacent side. Notice how the tides have changed. Depending on the angle, U has an opposite side over here and an adjacent side right here. This still stays the hypotenuse in both cases. So the tangent now is going to be of U, the tangent of U is now going to be 4/3 versus 3/4. So direction and location matter. You always want to be very careful when you go to write these out. All right, now we want K. Now we want to work with this one. We don't need anything more because the hypotenuse is here. The question is this the opposite or is this the adjacent side or is this the opposite or adjacent side? That's our question. Depending on J or K, it will make a difference. So let's see, it wants, write the tangent ratios for angle K first. So we'll do tangent of angle K equals opposite over adjacent. So the tangent of angle K equals, and then we'll do tangent of angle J will be in purple. Okay. Again, we're doing angle measure here, side length here. You don't want to mix those up. You want to keep them separate. Don't get confused if they give you an angle. All right. Tangent of angle K. Okay, so tangent of angle K. Tangent of angle K looks like this side is the adjacent side. Third time's the charm. There we go. And this side way over here is the opposite. So the opposite is going to be, so it's going to be 3/7, opposite over adjacent. All right, the next one, tangent of J. Looks like this one is the adjacent side. This one's still the hypotenuse. That doesn't change. And then this side over here is the opposite. So we have 7/3. That's my ratio for that one. Again, we're just writing ratios, not solving for anything yet. It says, how is tangent K related to tangent of J? Okay, the answer to that is they are reciprocals. They are reciprocals. Is it reciprocals? Let me look up to make sure that's spelled correctly. RECIPROCAL. Yep, that is correct. I am going to clean it up though. ALS, reciprocals. They are reciprocals. And a reciprocal is it's the product of one. So they are reciprocals. We'll leave it at that. But what does that mean? That means that like if you do 3/7 times 7/3, you get 21/21, which is 1. So they multiply to be 1, but the reciprocals are the flip of one side. Okay? When you found perpendicular slope, you flipped them, right? You flipped one of them, and that was called a reciprocal. So it was called an opposite reciprocal for perpendicular slope. All right. This one now, let's actually find the value of W. So in this case, what you want to do is you want to set this up. We're going to be using tangent. Okay, what colors haven't I used? Orange, blue. I haven't used light blue. Okay. So we are going to find the tangent of my angle, which is going to be equal to opposite over adjacent. So let's find the tangent of 54 degrees. Check this out. I'm going to actually put in a number now for my degree measure. And so the tangent of 54 is equal to, that's going to be my opposite over my adjacent. Okay. And the hypotenuse here, again, is not used. So tangent of 54 is equal to W over 10. Well, notice I don't have a side length, but we want to solve for W to the nearest tenth. So what I'm going to do is I'm going to multiply both sides by 10. So if I multiply this side by 10 and this side by 10, it will remove this from the denominator, making it W is equal to 10 times tangent. I just flipped it. W is by itself, so I put it on the left-hand side, and I'm just putting that on the right-hand side just because it's a little easier to write. 54 degrees. So W is actually equivalent to that. So let me go in and let's find that. Now, here's the most important part. You want to make sure that you are in terms of let's see, trig. We are going to do tangent. So we're going to do 10 tangent of 54. All right. And the most important part is knowing whether or not we are in degree mode or in radian mode. Does this calculator, let's see, do we have stats, miscellaneous? I don't know where the setting is for Desmos on here. There we go. So what I did was I clicked settings up here and I put it in degree mode. That's the most important part. Notice radian mode gave me, notice nothing in my entire set changes other than this last answer that I have. Let me get rid of some of these. Okay, so this most recent answer, 10 tangent of 54. Notice that changes. So we want it in degree mode. Why? We're using degrees, right? That is a degree measure. So we get 13.763. 13.763. Move that up over. Okay, 13.763. I think. Yep. Okay, and that's going to be, we want it in the nearest tenth. So W approximately equals 13.8. There we go. Take a look. Remember, the smallest side is across from the smallest angle. 90 degrees will have the largest side, right? Same thing. Largest side is across from the largest angle, so hypotenuse is the longest. If that's a 54-degree angle, let's do 90 minus 54 is 36. right? 30, 80, 90. Yep, so this is a 36, meaning that what's opposite my 36 is going to have to be smaller than everything. So 10, if W is 13.8, that makes it make sense. 13.8, it should be greater than 10. And that's why I knew right away I was in the wrong mode with 6.73. That would not have given me the right answer. Here's a quick way of knowing you're in the right mode. Type in sine of 90, and if you get 1, you're in a good spot. If you're in the wrong mode, you'll get 0.893. Nope, just do sine of 90, or you can even do cosine of 0. Okay, you'll get 1. Check out what sine of 0 does. Sine of 0 gives you 0, and cosine of 0 gives you 1. Oh, sorry, I meant sine of 0 and cosine of 90. But the reason why you don't want to test those is look at your mode. Right, it gets a little funky. Sine of 0 is still 0. So we don't normally use those. I would use either sine of 90 or cosine of 0 to get 1. And you'll know right away that there's a problem. Oh, well, sine of 90, see, that stays consistent. That changes, but cosine of 0 stays consistent regardless of what mode. All right, so just do sine of 90, get 1, and then you'll know you're in the right mode. All right, on another problem here, we have this one. So we're going to do the tangent. Let's see, we use blue. 1, 2, 3, 4, 5, 6, 7. Dark purple we'll use. Okay. This one's going to be, that's going to be opposite. This one will be adjacent. This will always be the hypotenuse, no matter what angle I pick. Notice I don't have to use 28. I could use this angle over here, right? But they already give me 28, so I might as well use that. So I'm going to do the tangent of 28 equals 1 over, well, it's opposite over adjacent, right? And so the tangent of 28 is equal to 1 over W. What you have to do here is you have to either know a lot about proportions, like I can literally switch these two numbers and it's good. You can switch numerators and denominators. Boom, you can move W right there and you can move tangent down there and you're good. You solve for W. If you don't see it that easily, what you can do is now do something like this. Multiply both sides by W. You get W times tangent of 28 degrees equals 1. And then you can divide both sides by the tangent of 28. And you get W equals 1 over the tangent of 28. Just like I said, you can just flip them, and then you're good. Or you can find your cross products. You can do W times tangent 28, 1 times 1. This is an assumed 1 on the diagonal. So you get W tangent of 28 equals 1, regardless. All right, so let's do, first off, I'm going to move this over just a bit. I feel like I wrote a little bit too much, but okay. 1 divided by tangent of 28. We're going to make sure we're in the right mode. 1 divided by tangent of 28. Make sure you're using tangent, not tangent inverse. That's the one, that's this one right here. You don't want that one. You don't want the negative, the tangent inverse is what that's called. Okay, we get 1.88. 1.88, which is approximately 1.88. So W approximately equals 1.9 because we're rounding. What I like to do sometimes is what I'm going to show you in the next one is solve it, using the easiest method. You can use either 33 or 57, and I'm going to model both of them. I'm going to show you that both of them will work. It doesn't matter which angle you pick, as long as you don't pick the 90 degree, which you can't do. Okay, so I'm going to do, we're going to do, whoops. We're going to do method 1 and method 2. Just to prove it doesn't matter what angle you pick. So you don't need to be like, oh, did I pick the right one to work with? Let's move that down a little bit. Here's the thing. This will always be your hypotenuse here. This will always be the hypotenuse. But depending on what angle I pick, we will get the opposite, and the adjacent will switch. So for this one, for 33, this will be my opposite. This will be my adjacent. Well, that didn't work out. Okay, so in method 1, the tangent of 33 degrees. I'm just going to go right into it without writing tangent equals opposite over adjacent. But it is equal to the opposite 2.5 over the adjacent, which is W. So what I'm going to do is I'll multiply both sides by W. Even though, again, I can just flip these and I'm good, it's going to end up being 2.5 divided by tangent of 33. Just switch this denominator with this numerator and this numerator with this denominator and you're good. But I'll do out the steps. So W tangent, I like to write it W times tangent of 33 degrees equals 2.5. And then I'll divide both sides by tangent of 33 degrees. And I will get W equals 2.5 over tangent of 33. And that's approximately equal to, let me rewrite this. This isn't that nice. That looks much better. Okay, 2.5 over tangent of 33. $3.849, actually 849, which, what was it, 849.849, 3.849, which even the round, 3.849, even the 9 rounds up, but we're rounding, in this case, we're only interested in the 4, right? What you can't do is you can't round that 6 up to make that 6 a 7, and It won't let me select. You can't round that 6 up to make that a 7, round that 7 up to make that 9, a 10, and to make that a 5, and you can't just keep rounding, rounding, rounding. So what I'm going to do is I'm going to ignore that 9 there. 0.84 does not round up, so we get W approximately equals 3.8. That's to the nearest tenth. 84 does not round up. Okay, so that's one method. Here's method 2. Method 2, right here we have this as my opposite. Well, this is my adjacent side. So this is the hypotenuse. We have this, I'll just move this right there, hypotenuse. And then we have this as the opposite. So the tangent of 57 instead equals the opposite, W, over the adjacent 2.5. This one's much easier. See how the W is in the numerator? There's not too much I have to do here other than multiply both sides by 2.5. Again, finding the cross products, W times 1 is W. 2.5 times tangent 57 is 2.5 tangent 57. So multiply both sides by 2.5. Let me move this over just a bit more. Whoop. It's as far as we can go. So W equals, and that goes away, 2.5 tangent of 57 degrees. And we can write it with the multiplication sign in between. 2.5 times tangent, okay? So 2.5 tangent of 57 is exactly the same exact thing. Notice that these two answers are equivalent. So 2.5 over tangent 33 or 2.5 tangent of 57. And that's how the way it should be. So that approximately equals 3.84. So W approximately equals 3.8. So again, there's either method. If you would rather never have to do this multiplication here, always get your, if you can get your value in the numerator, use your other angle, and that will work. All right. Let's do, so those are inverses. Do I want to do inverses? Do I want to do sine? Yep. So let's do the inverses of tangent. Inverses are pretty easy. In this case, you're trying to find an angle measure. So we're trying to find given side lengths. It's actually pretty easy. It's actually much easier than what we just did. We're going to try to find the angle measure given the side lengths. So let's find measure of angle x. So the measure of angle x, so we're going to say the tangent of angle x equals the opposite over the adjacent. So here's x. This is always course, I put this in the way. So in this case, this is your opposite side. And my hypotenuse is always there, opposite the right angle. And here is the adjacent side. And so we have tangent of angle x equals the tangent of angle x equals 6 over 8. There's nothing else you have to do. Don't even simplify it. Go just do this. Ready? I want to flip I don't want x here. I want x over here. And I don't want 6 over 8 here. I want 6 over 8 here. That will allow me to find my angle measure. So you can do that. That's legal. It's actually legal. We're going to say tangent of 6 over 8 equals angle x. But it's not legal until you do this one little thing right here. This right here is called inverse. So what we did was we inversed 6 over 8 with the measure of angle x. So in this case, the measure of angle x is equal to the tangent inverse of 6 over 8. And we still want to make sure we're in degree mode when we do this. So I'm going to put that in our calculator. We are in degree mode. I'm going to do tangent inverse, which is this one right here. Notice how it looks different. I'm going to do 6 over 8. Whoops. And I get 36.869. 36.869. $36.869 to the nearest degree. We're going to say the measure of angle x approximately equals 37 degrees. That's it. So inverse, trying to find an angle measure given a side length, it actually, inverse means to switch inputs with outputs. And as long as you account for it, you can do it. So here's your input, here's your outputs. Flip your inputs and outputs. It's fine as long as you perform the inverse operation. All right, this next one, we'll do the same thing. So we want to find the measure of angle y. So angle y is here. This is always the hypotenuse, opposite the right angle. This one will be opposite. Look how far away it is. Here's our adjacent. So we have the tangent of angle y equals the opposite over the adjacent. So the tangent of angle y equals 100 over 41. Tangent inverse of 100 over 41 equals the measure of angle y. So the measure of angle y is equal to tangent inverse of 100 over 41. The measure of angle y approximately equals, let's see, 100 over 41 for tan inverse. tan inverse of 100 over 41, 67.706, which rounded to the nearest degree is 68 degrees. Boom, and that's it for tangent inverse. All right, for this next problem, a rectangle is 80 centimeters long and 20 centimeters wide. To the nearest degree, find the measures of the angles formed by the diagonals at the center of the rectangle. So the measures of the angles formed by the diagonals at the center. All right, so I was able to draw this out a little bit earlier. So here we have a rectangle that's 20 centimeters by 80 centimeters. And I'll put an 80 up here. It's not really going to matter, but there you go. What I am going to do is I'm going to erase, if I were to, let's say, get rid of one of these diagonals, what I'll be able to do, so I'll be able to find this angle here. We know this angle is a right angle, and then find this one here. And then I'll draw this other diagonal in, and then they'll be the same exact angle measures, and then we can find out what the angles, what they are formed by the diagonals at the center of the rectangle. So the first thing I'm going to do is I'll put a X right here. I don't know how many degrees that is, but I will find out. So I'm going to do, let me put in right angles. I'm actually going to do the tangent inverse of 20 over 80. So the tangent, let's see, tangent of angle X equals the opposite over the adjacent. So the tangent of angle X equals opposite over adjacent. So that's 20 over 80. So the inverse tan of 20 over 80 is equal to the measure of angle X. So now I'm going to do the measure of angle X, the inverse tangent of 20 over 80, and, tangent inverse, not tangent. It appears to be about 14 degrees. So we'll say that the measure of angle X is approximately 14 degrees. So if X is 14, so if that is 14 degrees, I'm going to rewrite it like this. Nope, maybe not. So if that's 14, that makes that 14 degrees as well. That makes, let's see, we're going to do 180, take away 90 is 90, take away 14, 90, 80, 76 degrees. So we get that this is 76 degrees. That means that this is also 76 degrees, and so on and so forth. So I'm going to draw this other diagonal in. That would make that 14 degrees, and that one is 76 degrees. That is 14 degrees and 76 degrees. Good, so I can either find this right here, 76 and 76, I can do some math. 180, take away 76, take away 76. 70, 14, so it's 40, 30, 28 degrees. So it's going to be 28 degrees. That one will be 28 degrees. And the other one will be 180, take away 14, take away 14. 180, 170, 160, 152 degrees. And so that will make that 152 and 152. And what you notice here is that 28 and 152 do add up to 180, which is exactly what you need if these are lines. So it says to the nearest degree, find the measures of the angles formed by the diagonals at the center of the rectangle. So the answer is they are 28 degrees, the measure of the angle, and the measure of the other angle is 152 degrees. Boom, that's our answer. All right, find the value of W, then X. Round the lengths of the segments to the nearest tenth. Round angle measures to the nearest degree. So we got nearest degree, okay? And we also have nearest tenth when it's talking about the segment length. All right, so what I'm looking at here in 27 is an isosceles triangle. Also, I have angles here, but remember, base angles of an isosceles triangle are congruent. So this will be 43 degrees. Okay. And notice that these angles are bisected. This angle is bisected because you have a perfect bisector here. That would make these 90 degrees. And so I can quickly do 180, take away 90, take away 43. So 180 take away 90 is 90, 90 take away 43 is 47. So these right here are 47 degrees. Not that I need this information, but let's take a look. What do I need to do first? I need to find, it says find W then X. I might have to find X in this case. Because if I go to find W, taking a look now, I don't see any way of really doing that because I don't know what X is. So I need to find X first. So I'm going to do the tangent of 43 degrees is equal to the opposite side over the adjacent side. So opposite over adjacent, and the tangent of tangent of, well, I guess I could have stayed 43. The opposite side is x, the adjacent side is 5. In terms of 43, I'm working with this 43 right here. Okay. And so maybe I should just put a little mark. That's the 43 I'm working with. Okay. And I'm going to multiply both sides by 5. So 5 times 5 times tangent of 43 degrees equals x. 5 tangent of 43. Okay, 5 tangent of 43 degrees. And we are in degree mode. It looks like it's 4.66. X is approximately 4.66. But it wants me to round to the nearest tenth. What I want to, yeah, let me think here. 4.66, let's get another number, 26. This is what we call an intermediate value. It's called an intermediate value because we're now going to use this value and I just approximated it. So I want to keep it as large as possible. So I'm going to say this is 4.7, okay, because I rounded it. However, when I go to calculate this next one, I'm going to work with 4.6626. You know, I might even throw another number there. What was it? 5.7. I rounded it to 6. Let me do 5.8. Let me go back and just make this a 5.8. Okay, 66258, 66258. I'm carrying a lot of decimals with me there. So that's my intermediate value. Now I'm gonna go solve for tangent of 43. So the tangent of 43 degrees, this other 43 is equal to oh, you know what? I don't even need to do it because if this is an isosceles, this is also perpendicular bisector. Whoops, I didn't even notice that. Okay, so these are also equivalent. So W has to equal 5. So we actually don't need to use this intermediate value. But if I wanted to use it, I could. Let's get rid of that. Now I'll leave that note there for you. All right, so in this case, we'll summarize it by saying X is approximately 4.7. I was going to use it to solve for W, but I already know that W has to be equivalent to 5. And W is actually equal to 5 exactly. Okay? Again, if you need to use that value, if you need to use it, so if you need to use this value, try to use as many decimals as possible. By that I mean just try to keep as many when you go to solve the equation. All right, this next one, we will do W first. So I'm going to do tangent of, let's see, 56 is equal to the opposite 10 over the adjacent W. Multiply both sides by W. So W tangent of 56 equals 10. Divide both sides by, divide both sides by tangent of 56. So W equals 10 over tangent of 56. Oops. So it was what? 10 divided by tangent of 56. 10 divided by tangent of 56. And it looks like that's 6.745. 6.745. 6.745. That's pretty good because then after that there's zeros. So I'm going to leave it like that because now I'm going to have to find this whole thing and then take away W, which is 6.745, right? Because I'm going to do the tangent of 34 equals 10 over all of this. I'm going to call that let's call that B. I don't know, I need a new variable. just because I'm going to have to do 10 in B, and then I'm going to have to take whatever B is and take away what W is, and that will give me X, because B is W plus X. Let me move. Let's erase that. That gets me a little bit more room. All right. So I'm now going to do tangent of 34 is equal to the opposite 10 over B. Again, you can just switch these if it's easier. So I'm going to, but I'll show you the work, times B times B. So B tangent of 34 degrees equals 10 divided by tangent of 34. So B equals 10 over tangent of 34. Which is 14.8256. 14.8256. Okay. And now what I need to do is do 14.8256 take away 6.745. Take away 6.745. And I get 0.808. I get 0.808. Oops. 8.08. So X is approximately 8.1, while W is approximately 6.8. But notice how I used that value. I used an intermediate value, okay, right there. All right, we are running out of room. Let's see. All right, this last one, we have W. This is an angle measure, so this one should be a little bit quicker. Tangent of W is equal to 5 over 3. Therefore, tangent inverse of 5 over 3 equals W. Degrees. So W approximately equals that, but hold on, I'll just do the next one, and then I'll go to evaluate these both in the calculator to save time. So tangent of X degrees is equal to 5 over 7. Tangent inverse of 5 over 7 is equal to X degrees. So X approximately equals, and let's see, so inverse tan of 5 over 3 and inverse tan of 5 over 7. Inverse tan of 5 over 3 and inverse tan of 5 over 7. So it looks like 59 degrees, 59, and 59, let me write this as 59.0362. And then this next one is 35.5376. I think it was 0.5376. Yep. Okay. And I'm going to write my final answer as W approximated. It wants it to the nearest degree. So I'm going to say about 59 degrees. And X is approximately 36 degrees. That's how those round. It's extremely important to round correctly based on what the question's asking. All right, that was a long lesson, but that is it for tangent and tangent inverse. Good luck on your IXLs.